Hello, and welcome to podcast.drchuck.com. My name is Charles Severance, and I'm the host of this podcast. This podcast is recorded and broadcast live on YouTube. About once a month, I have live open office hours with my online students on Coursera and other learning platforms. Each month, I come up with a topic to talk about for 30 to 40 minutes, then spend the rest of the 2-hour live event as an Ask Me Anything, answering whatever questions come up in chat. You can find either the previous or next live event at live.drchuck.com, and you can find my YouTube channel at plus.drchuck.com. And my online programming courses are available at online.drchuck.com. Welcome to the podcast. Okay, well, I have a feeling that we are working just fine. Hello, everybody, and welcome to, wait a sec, gotta get my coffee. Hello, everybody, and welcome to the live stream on Friday morning, May 24th, 9 o'clock in the morning. I invited my Coursera students and all those folks. Here, let me move this somewhere else so I don't have to watch myself talk a little bit late. And so, again, welcome to all my Coursera students. So the format of this generally is I talk for about maybe a half hour about some topic, kind of like my little every couple of weeks TED Talk. If I had a TED Talk every couple of weeks, maybe kind of like a podcast. And then at some point we switch to your questions and answers about the Python course, the C course, Django course, online teaching in general, anything that people want to talk about. So I am going to go ahead and I am going to start my presentation. So let me set my cameras up for that. And there we go. Let's, I think that, yeah, maybe I will put myself in the lower right-hand corner. So that is what you should be seeing. Yeah, okay, so that works. Okay, so, there we go. So basically, I just finished this course, ccfree.com. It is on Coursera. It's getting some uptake. It's in some ways, it's my masterpiece. It took me 4 years to build this course. I started building the course before the pandemic. When I build courses, I start by building auto graders. This course had a special aspect to it because I needed to create a textbook. And I created a textbook by getting copies of this out-of-print 1978 book. I probably have about 100 copies of this now because I bought every used copy I could for like a year until I found a really perfect one. I cut the spine off and then I digitized it. And then I created the book that is now on CC Free. I had graduate students do typographical error checking on it, built unit tests for all the sample code, made sure that I could compile the sample code with a modern compiler. I have to put tons of compatibility options because the variant of C that is in 78 is not the same as the modern C. And so that took me a long time to build a book, to build a way to execute code in the browser because I always want to make all the online courses that I create be exceedingly scalable. And to do so, I need to create, like, when students submit code to a system, you have to assume that that code is kind of attacking you because you can't just take student code, run it on your computer, just drop it in, compile it, run it, because it could, format your hard drive or remove all your files or delete your database or something, right? So, and it's pretty easy. Easy is not the right word for it, but you just have to assume it's easy. You have to assume that, So people are seeing us on LinkedIn, so that's cool. Seeing us on YouTube. This is the first time I've figured out how to time it in such a way that I got it up on YouTube. And so you have to protect this stuff. It's so building an auto grader and making it so students can execute code. it's so difficult for students to install a C compiler, install an editor. Now, if you already got that, that's great. But if you are a beginner, which I always sort of try to make my courses for everybody, it's really nice if I can give you a browser-based environment that allows you to do most of the work in the course, because then your installation and the tech support required for the installation of your stuff. So all I'm saying is that this was kind of a masterpiece for me. I mean, I've been building online courses for a long time, and there are so many things in this course that I have done the best I could possibly imagine doing. One of the things has to do with blind and low vision users' accessibility, which is in most courses an afterthought, kind of to protect from legal trouble. I have been thinking for almost a decade now about how to create materials that appeal to blind and low vision users, even on yeah, hey everybody coming in, that's cool, it's good to see you. I will talk to you in the chat in a little bit. And so I've tried to create, I mean, maybe I'll show you at some point some of my techniques for that. Would be another good TED Talk, just talk about blind and low vision users and that kind of stuff, and how much that means to me and how much effort I put in. The simplest thing was I read the book, and I not only did I read the book, because reading the book is kind of only half the battle. I also made sure that the book was in HTML pages, and blind and low vision users are really good at HTML, as long as you make the HTML accessible. And if you want a blind user can sort of zoom, page through a book really fast, right? If it's in HTML, and so that I wanted them to be able to move around. But again, the masterpiece. And so I spent so much time building this course. And the other thing that happened in this course is that, and if you go into it, you'll see I have these a poem from Robert Frost. And originally I decided that I was going to stop the course before chapter 6. And it had to do with the fact that I just thought I was teaching the C programming language, and I didn't want to teach complex data structures, because that turns out to be a rather computer sciencey topic. I didn't want to mention C++. I wanted to treat C as this really small, basic, close to the metal language. And I taught the course in winter 2023, so that'd be January through May 2023, to a small 15-student class at the University of Michigan. And I said, we're done now. And they're like, no, you're not. You got to talk about C++. You got to talk about objects. You got to talk about linked lists. And some of these students had taken a C or C++ class, and they liked it. And I thought, oh, that's too hard. And they're like, no, if you don't explain that stuff, you're doing your future students a disservice. So I scrambled and I redid a whole bunch of stuff. And I really, if you go on to Coursera, the 4th course is really something that was added because students who I exposed to the course insisted on it. And so I was like, go and make all this new stuff and remake lectures and do all this stuff. And when I was teaching chapter 6, and chapter 6 in this book is chapter 6 in the book is called Structures, which is linked lists, pointers, all that stuff. Chapter 5 is pointers and arrays, and I was teaching that, but then I decided to teach chapter 6. So the problem is you got to figure out, I didn't just want to teach linked lists, which is in the book. I wanted to, so I'm like, oh, hey, look, Python has a list object and a dictionary object. And so, off I dive into a whole narrative of how to use linked lists to implement the Python list object, and how to use hash maps with buckets and chains, also known as the most popular code interview question in the universe, hash maps with buckets and chains. And I wanted to use that for dictionaries. And then I wanted to talk about abstraction. And then I brought C++ in and talked about how there's this concept, this abstraction of maps, key value pairs, and arrays/lists. And all that stuff, it's like all of a sudden I realized that, because the students were driving me in that direction, that I really was talking about object orientation. I was talking about the concept of an abstract interface and an implementation below that abstract interface. And if you look at my Django class and the Python class, teaching object-oriented programming is one of the hardest things that I find in all of teaching programming. And I'm like, oh wow, this course has turned out so cool because I've found a way to teach object-oriented programming. So if you take Python for Everybody, it kind of introduces self and object-oriented programming and methods and attributes and terminology. And I consciously, in Python for Everybody, keep it really simple, knowing that we're going to come back. In Django for Everybody, we use a lot of objects, we do a lot of work, self is all over the place. I'm not sure students understand it as well as they should in Django for Everybody. And then here I am in C Programming for Everybody, and I felt like the explanation in the last part of C Programming for Everybody was just magnificent. I'm like, this is, if students can understand what I'm teaching here in the 4th course of C Programming for Everybody, they're going to understand objects like the rest of their lives, as well as some of the best and most experienced programmers. I think objects completely different than the way a student thinks objects. I think of objects as things that solve my problems, right? Ways that I solve my problems. So I built this class, finished it up. I was in a hurry to get it on Coursera, so fall 2023, 6 months ago now, 8 months ago, 10 months ago, 8 months ago. Fall 2023 at Michigan, we started the sprint to put it up on Coursera. And again, I'm sitting at the end of a 4-year effort. And I was all like blinders on. Let's finish this thing. Let's get it up. Let's get it on Coursera so that you students can see what I thought was the most beautiful course that I've ever produced. And so we finished. We finished the 15th of December, 2023. It went up on Coursera right on time. And that was holiday time. And so I had 2 weeks to relax. Class was, I wasn't teaching. 2 weeks to relax. And I kind of started reflecting on what we had accomplished. And I'm like, whoa, I wonder if I inadvertently was unintentionally following the path that Guido van Rossum followed Christmas 1989 when he started writing Python. Python came out like early 1990, and he just kind of, like me, started a crazy idea over a holiday break. And I'm like, whoa, wouldn't it be so awesome if the code that I built in C Programming for Everybody was exactly the same as the code that Guido built? Okay? And so I'm like, I better answer this question. Now, there's a couple of ways I could have gone about answering the question. One of the ways I could have gone about answering the question was I could have looked at the source code to the dictionary and list implementations in GitHub, because all the Python code is in the implementation of Python, which of course is C. I could have read all that. I could have figured it all out. And I have looked at it from time to time, but it's big. It's a lot of code. And I was pretty confident that I knew what I would see if I looked at that code. And so I thought the more interesting question is to talk to Guido van Rossum about that, right? Oh, hey, I went to the Python a couple weeks ago. Let me show you this. I don't know how well you can see it. This is my cardboard cutout of Guido van Rossum that I got at the Python conference. Like last week I was there. This was at auction. You'll see that it's signed by Guido van Rossum himself, front and back. And so I will put him back here. So Guido van Rossum is kind of, so he's back there. He's always present. He's sort of behind me, sneaking around, peeking over my shoulder while I'm doing live streams. So one of the things I want to do is I want to take Guido van Rossum's cutout. He might get mad at me for this, but I want to take Guido van Rossum's cutout like in my race car, on my boat, and when I start flying, I'll bring Guido van Rossum in the airplane, and he'll probably be mad because he's kind of a quiet, he's a quiet, reserved fellow, and so here I am, like, hauling him out in all kind of social media situations. So I thought to myself, I'll just ask Guido. I mean, because you've probably heard the story that, like, in February of 2023, I asked Brian Kernighan if I could go out to Princeton and film him, because, you know, I'm an amateur documentary filmmaker, right? And so I sent a note to Guido and asked him if I could come out and film him as we have a conversation about the internal implementations of list and dictionary in Python. And that visit to Guido's home in Northern California was quite surprising. And that's why I call this the plot twist at the end of the C Programming for Everybody movie. And eventually this will be on Free Code Camp, and it'll be like a movie. It'll be like 13 hours of stuff, and then there's going to be this plot twist at the end, an extra hour or so. And with that, let me switch to my screen and go through some of the PowerPoint from what I call the epilogue. So let me switch to the screen. So let me put myself back in here. So there we are. So this is the, if you go, let's let me get another screen here. If you go to www.cc4e.com, which has all this stuff, you can right this minute go into lessons and go into the epilogue. This material is not yet in the Coursera course. I've just met with the University of Michigan people to get this put in. And so, but this is all of it. There's like this welcome, this is the video for welcome. Then I have 2 interviews with Guido. One talking about like the internal object implementations inside Python for 20 minutes. And then we got talking about where his inspirations were. And I'll summarize a lot of this. I'm not going to show you all this. And there's just so let's see, it's 18 minutes. That's 30, 43, 54, 59, 69, 74, 11, 74 and 40 is 110, 130 minutes. So 130 minutes, which is about 2 hours. So this is like if you watch all this stuff, which you will on Free Code Camp, this will be like a 2-hour epilogue to an otherwise like 12, 14-hour movie that is all of this stuff. And it includes the reading. So if you go in here, you see the, well, that's the wrong one to look at. You actually see the readings of the book. And this is not just video. It's a YouTube video, but it's also an audio, and you can get this from a podcast. And I think that's audio.ccfree.com. Yep, there you go, audio.ccfree, and you subscribe to that on your podcast. And I thought, maybe you could learn C programming in your car listening to a podcast. Please drive safely, of course. Oh, so okay, so that's the book, but I've got this all set right now online, free, no cost, at ccfree.com. And so you can see it as much as you like. So it begins, and here's the PowerPoint, and this is the PowerPoint that I'm going to talk about right now. Okay, so I have this saying, and I just made this saying up, but it's a saying that means a lot to me, and that is, you think you're done with something, and C Programming for Everybody, I thought that I was done with it, several times. And then all of a sudden a surprise happens, whether it's my students telling me that I needed to cover linked lists in C++, or me realizing that maybe I should talk to Guido van Rossum about it. And so in the class, what I had done was I just was teaching this book, right? I was teaching this book. And I was just looking at this book like any teacher would, and just like, okay, how can I come up with something that explains this page? And then, how can I come up with something that explains this page? And on, and on, and on, right? And so I had this very heads down view. And I just have been a computer scientist. And all computer science curriculums have been affected by this book, whether they use this book or not. So all computer scientists always teach linked lists. And all computer scientists teach bucket hash maps with buckets and linked list chains. And again, this Kernighan and Ritchie chapter 6 was like our guide. It was our guide, And whether you're teaching, you could teach in a whole different language, but you're still going to teach the concepts, the outline of the concepts from this book. And so this book was like the foundation upon which we built all of computer science. And so my theory was, so let's see, there's some pictures here, right? We built, and this is all in the class. I'm not going to go through it again, but we built a really cool extendable array. And the key thing is it uses realloc. And when you do dynamic memory in C, you do free, malloc and free. And most things that we computer scientists think about are malloc and free. Realloc is a rare thing, but when I was building this string, the string just kind of keeps growing, and why not use this thing that we rarely used in computer science called realloc, which says, hey, C and the operating system, you gave me some free memory, let's just make it bigger. And it copies the part in, and so you kind of know it. And it's a really elegant concept. And so when I was in the course building the string, I didn't use a linked list to build a string. That would be crazy. So I did that. And then I built the Python list class. And here I just have like, ooh, it's a linked list. Why? Because I do linked lists in my sleep. It's like a thing we do in computer science is linked lists. We just do it. And it's, whenever I write this code, and I wrote this code so I could have sample code in the course, it takes me a while. Meaning that I've done this 100 times in the past 30 years. And I always can make it work. But these lines in the middle, these about self-head and connecting the new thing to the end of it, self-head, self-tail, and what order those three lines have to be in, I always figure it out, but I always have to draw a picture to figure out those three lines. And that's why it's so fun for computer science to teach linked lists, because you can it's like easy once you know it, and it's difficult until you do know it, and it's elegant once you see it. But it also, no matter how good you are, there's a certain difficulty in making it work. Okay, and so it's kind of like, it's that perfect blend of complexity and elegance and satisfaction when you know it. And I, every time I get my linked list working, I'm so satisfied. And so again, I just went through and thought, oh, that's how Python did it. And so of course I'm mentioning this whole, adding a new thing to the end. That's the tricky part, and that's where this code is right now, but it probably wasn't right for the first 10 minutes I'm writing the code. And I'm like, oh wait, I got to do this thing in this different order, or blah, 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 blah. Self, tail, next equals new. What is that? Well, that's the old tail. The next equals the new thing I just added, right? Okay, so again, so we do a dictionary class. And that uses hashing. Of course, hashing takes a big string of data and moves it, does some kind of sort of recombinant algorithm, exclusive OR and shifting, and exclusive OR and shifting, and whatever, until you got something that can be moduloed down to some finite size thing. And so if you have a hash table with 16 entries in it, you modulo 16 and get a number from 0 through 15. But the data can be extremely large and scanned really fast with some kind of a recombinant numerical calculation that gets down to that. And then what we do in the classic Kernighan and Ritchie is we have in effect, however big our hash map is, that becomes a set of linked lists. So it's really quite simple to build this, especially if you just got done building a linked list. A hash map is really nothing more than multiple heads, multiple beginnings of linked lists. But once you start at the right head based on the key running through the hash, getting to the right bucket, it's a linked list traversal. And then there's little things about reallocating and making it bigger when the chains get too long. And again, what I'm talking about now is I'm talking about what they ask you to write on a whiteboard when they say, draw a picture of a hash. It's not the picture of the hash inside Python, as we're about to find out. And so, It's what it looks like because it's got multiple linked lists and there's next pointers and all that stuff. But again, once you get to the right head using the hash, it's really just a linked list problem. So this is where I decided I would go see Guido van Rossum and fly out to his home and take a copy of the Kernighan and Ritchie book. And it was kind of funny because Guido and Guido apparently seemed like it was a fun thing to talk about. And I think not a lot of people are old enough. Everyone's just like, Python miracle, let me talk to you about how miraculous it is and how pandas works great. And I think he's sort of like, I don't think enough people care about the beginnings of it, because that's when it was him, right? And so he seemed to enjoy the idea that I was going to come out and talk to him about the first weeks, literally the first weeks of Python. And so what I did was I brought him a gift. I had taken copies of this book with me to Brian Kernighan's office at Princeton a year earlier, and I got a bunch of signed, I have like 5 signed copies. And again, that's out of print, you got to buy it used, etc., etc., etc. And so here I am, I hand it to Guido. And I say, Guido, turn to page whatever, chapter 6, and leaf through this book. Again, this is a situation where I did not understand, I did not know the answers to the questions I was about to ask him, right? I didn't understand it. And so I said to Guido, just skim through this. And he skimmed through for a while, flip, 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 flip. And then I said, do you recognize chapter 6? And he goes, well, I'm sure I've seen it at some point. We all saw it. We all used it. But I don't really recognize it. I said, did you use this book as like the blueprint for the data structures in the first iteration of Python? Did you use this book? Because I use this book to build my Python data structures. Because again, I'm a trained computer science with a PhD, and I've been taught and I just thought, of course you would. And the interesting thing is, no. I wouldn't say that Guido van Rossum doesn't like linked lists, but he might not like linked lists. He just thought in some ways, I'm kind of guessing and projecting a little bit, that Guido probably just thought linked lists were unnecessarily complicated. And part of that was because the thing that came before Python, and we always say ABC came before Python, right? Python, ABC didn't use linked lists. It uses a thing called B-trees, which is a very database concept. And he just looked at that and he said, what a complex mess. And so at some point I asked him, I said, of course you used linked lists for Python lists. And again, when you watch these videos, you will see that I am confused when I'm asking the questions. Usually I'm often confused. Like when I was talking to Brian Kernighan in early 2023, I was confused in that interview too, and he would keep correcting me, but I just cut out all the parts where I was confused. But the Guido interview, I didn't cut all the parts. I was very confused. I really was very confused as we were talking, and I didn't cut all the confusion out. So I'm like, you didn't use linked lists. I'm like, what did you use? And so he uses arrays. I'm like, arrays? Why would anybody do that? And again, I'm confused during the interview. And it wasn't. He didn't like linked lists. He didn't like linked structures. And so he said, it's just an array of pointers that I realloc, which is kind of like what I did when I built in the class. I built the string class. I realloced it. I just made an array of characters, and then when it got too big, I realloced. He said, that's what I did for list. And I'm like, oh man, that's so not computer science. You're not doing what we computer scientists would have taught you to do if you really studied well in a data structures and algorithms class. Of course you'd written a linked list, because it's what we do. And then I asked him, I said, okay, after we talk about linked lists, it's a 20-minute interview, and you can watch it at your own time. And then he said, and I said, okay, great, you don't use linked lists, but you use arrays instead. Got to drink some more coffee. I said, well, please tell me that at least hash maps use buckets and linked lists from buckets. And he said, kind of like, Chuck, you did not hear what I said. I don't like linked lists. And I said, oh, how can you do a dictionary without hash maps and linked lists and buckets? And he goes, well, I use an array of pointers. And I'm like, okay, explain to me how that works. So it turns out he had taken a different book. This book is Knuth Volume 3, Sorting and Searching. This is a much earlier book. This is like a early 70s book. Donald Knuth was like the algorithms god. And everybody there's three volumes of this, Volume 1, Volume 2, and Volume 3. And I don't know if you can see this, but it is really very, very explicit. He would create algorithms, and he would show them to you in this very assembly language-like way, which meant that we as software developers he broke it down to the simplest thing, like how a machine would actually do it. And so here on page 514, there's some more code from the Knuth book right there. That's his way of showing us an algorithm, because you can't, it's a little longer and more complex, but you can't get it wrong. I mean, if he can show it to you in machine language or assembly language, you can't get it wrong. And then he has all the math and stuff to prove it's a good idea, which, I don't care. And so Guido found this thing called open hashing with linear probing in this book, and he read all this stuff, and he goes, oh, that's a great way to build dictionaries, right? And so he made open hashing. And so then what I do in the class, in the epilogue, is I go and re-implement the Python linked list the way Python 0.9 did it back in late 89. And so what he did was he just made an array of pointers. And you can watch this whole thing. I'm not here to do this whole lecture over and over and over again. It took me 2 hours to do it at the fastest pace I could. But basically, it's just an array of pointers, and they are extended. When you run out of space, you just reallocate and make it bigger and have more pointers. And if you think about it, and you look at the code here, you're like, that is simpler than a linked list. And the reason why we software developers and computer scientists software developers, we never trusted the reallocate code. And part of the reason is that we knew as how hard reallocate was. Reallocate is a hard problem. Java has this concept called garbage collection, and it's been 20 plus years that garbage collection in Java has been its Achilles heel. And so, but we knew that, and if you look in the Carnegie and Ritchie book, they even talk about how hard memory allocation is and reallocation. And so for me, as a computer scientist, my theory is don't use reallocate. And if you use linked lists or hash maps with chains, you tend not to reallocate anything, hardly ever. So you're mostly creating dynamic memory and then giving it back and then getting more and giving it back, but not using reallocate. But that's kind of a fallacy. I mean, eventually Guido told me that they depended so much on reallocate and they were disappointed, at least 10 years later, where Python was starting to be real and needed to perform better. They just cut out reallocate and they did their own reallocate, and they did their own garbage collection and all that stuff. And the reason is that Python itself could manage its memory better than C could. C is managing at a much lower level for many different applications, Python only being one of them. Why not create a memory allocator and garbage collector that is unique to Python? And so this notion that reallocate would be used for lists as they grew, they could start really small and they'd reallocate up, And then dictionaries could also start small and reallocate up. And so it's kind of a pretty thing. And so it just, you can look here in the upper left, you see the linked list structure and the amount of sort of like extra crud that's in that. And then you just see the really elegant structure that is really Python 0.9. It just is an array. And the code, while the code is not particularly trivial looking, the essential part is just you have a pointer to the, you have the size of the allocated bit, and then you add 1 to it and put a pointer in. It's like, in some place, I can look at this code, and it's not much shorter, but I can validate that I got it right. Meaning that my time from the time I start writing this code to the time I believe it's correct is much shorter than the same code that I would write with a linked list. And I'm familiar with both techniques. It's just linked lists just kind of require, a bit more effort, right? So, and then I go through his Python 1.0 dictionary from the Donald Knuth sorting and searching, and then I drew this thing. It uses this the conflict resolution is when a hash value has a collision, because it's starting with a big amount of data to a small number within a very specific range. Collisions are inevitable, so you have to have collision resolution. And this book, the Knuth book, does a reverse circular search. So it goes from where it should be. If that's full, it just works its way up, and then it goes down to the bottom and works its way up. It turned out that was easier for Knuth to write the loop. For us, the way we would tend to write the loop is to go down and then go back up to the top using a modulo operator, but Knuth did it differently. So if you're reading the Knuth book, you see that it's a reverse circular search, whereas the code I'm going to write is a forward circular search. And so basically, if you look at it, it's an array of key value pairs, and the dictionary itself is an array of structs, not just an array of pointers. A list is an array of pointers. This is not an array of pointers to structs, but an array of structs with key and value, and the key is a pointer and the value is a pointer. And I just made it string. Some of my code does like integer to string or a string to integer, but you can see the key value. And then when it fills up above some size, you got to reallocate, and I go through all that. And then all of a sudden you got a bigger one, and you got to copy all the things into it, and then you've copied these things. You don't reallocate the actual objects. You're really just reading the pointer values, copying them in, and then you get rid of the 2-size dictionary and go to a 4-size dictionary with a load factor of 50%, and then you can insert some more stuff. Now there's no chains in here, right? You have to reallocate the whole dictionary and make it big, and then you can't just do you can't just copy the stuff because of the conflict resolution, so you actually just have to reinsert them. And I have all the code for that. It's not that hard, and I walk through all that code in the lectures. And then we add some more stuff. And then I asked him at the very end, I said about the Python 3.7 order dictionary, and that's really beautiful, where it's in insert order, not sorted order. So there's no interest in sorting it, although some data structures in C++ and Java can have like a tree map which sorts by keys and stays sorted by keys, and we actually cover that in the C programming for everybody. But it ends up being it's probably it is the most complex part of C programming for everybody. But all he did was the key value pairs are now a linear list, and so I'm not sure that shares code, but it's a list of key value pairs, which is indexable by it's an array, so 0, 1, 2, 3, and the hash part is just a separate little data structure that is an array of integers, because this integer is the position within the key value array. And it turned out that because of the way hashes work efficiently, you can't really get above a load factor of 70% full and maintain efficiency. Whereas in the Python 3.7 and later dictionary, you can get 100% of this array at max efficiency. And the way I built it, I made this index array twice as big as the data array, and so I never get a load factor of above 50%. The reallocation is really simple because you don't touch any of the data, right, that's in the key value pairs. You just make the index bigger. You extend the the list as a list of key value pairs a bit. And so there's this beautiful symmetry between the Python 3.7 dictionary and the Python 0.9 list. And so that was the first part of it. And so, of course, there is always more, my Steve Jobs moment. And that is, he and I, after I kind of understood everything I just told you about, started talking about his inspiration. And I always love this chalk diagram that I stole from School of Rock, where I show what influenced what. That's what I'm showing on this diagram. And what you mostly have seen is me talking about where the C language fit and how C influenced. Like C, the moment C was created, whether it's 78 or 87, 72, C changed a lot of things. And so that's what this picture is. And again, that's because C Programming for Everybody is a C class. But then we really started talking, and a new picture started appearing in my mind, because now I'm talking to Guido. So my C class is becoming a Python class. It all comes back to Python. And so I'm like, okay, so let's change this, and let's look at all the influences that led to Python. Not look at the things that C influenced, but instead look at things that Python were influenced by. And the coolest part about this is the modula influence. And then I was talking to one of my teaching assistants, and he said, yeah, Smalltalk has that too, the self concept. I'm like, where did that self come from? Well, Guido saw it from modula, which he met some people at a DEC research center. But then if you do some research into modula, and the problem was I didn't even think modula. I used Pascal, and I thought modula was kind of, by the time modula 76 came out, C was out, and we just weren't looking to ETH in Switzerland for the future. But modula was a great step beyond Pascal, and then modula 3, which was an object-oriented step beyond Pascal. But modula 3 was also influenced by Smalltalk, which was influenced by Simula. And so Python, again, he's European. Guido lives in the Netherlands. Modula, I think, might have been from Italy at a research center. And so, he saw things in the mid-'80s that I didn't see. And so the whole concept of self, he said, was taken from modula. And so it's quite beautiful to see how thoroughly he looked to every other project, evaluated every other project. He was like trying to create the greatest thing ever, and he was doing that by learning as much as he could by every other language that he could touch. So that's pretty cool. He also wrote some code in C++. I think that at some point in his mind early, he thought, oh, C++ will have so many cool features that it'll make writing Python easier, and it didn't. C++ is not sort of a layer that simplifies and beautifies C. It is a much more powerful tool than C, and it kind of gets in your way. But if you want its power, there's nothing like it. And so he did some work in C++, kind of prototyping work, and then he learned about C++ and was inspired by C++. And so C++ was definitely an influence. I think it was so much that he thought he might use it, but I think he gave up on it when he couldn't accomplish what he wanted with C++ and realized, I just got to go one layer lower and just do the hard work. And that was a great choice, right, to choose C as the language. ABC, one of the things that this thing taught me to do is to look a little more at ABC, and ABC was a pretty cool programming language. And so you see, if you look at ABC, you realize that there was a lot of things like split, trim, in, for, for in. You see Guido like really inspired by the programming language, the end user view of it, and it's really it's kind of pretty. And so he was the inspired by ABC is way more than what that sounds like on the surface. Right. So he didn't like the B tree structure, which is a very linked. It's like B trees make linked lists seem simple, but they're all pointer-based structure things, and then Module 3, like I said, had the concept of self, and so the last thing is my interview with Guido, the second half of the interview with Guido, where he talks about object orientation, and I let him finish the course. I let him finish the course. He gets the last word in my C programming course, ironically, and this epilogue really completes the transition of what I set out to be a C course to it becoming a Python course. And so I love how it turned out. I hope that a whole bunch of students take Python and then they want to be a better programmer and they take C right away. And instead of saying C is the language to learn data structures, I want to say C is the language to understand Python and understand Python deeply.
We hope you enjoyed this episode of the DrChuck Plus podcast. To find out when the next live event is, visit live.drchuck.com. To find DrChuck's YouTube, visit plus.drchuck.com. And for DrChuck's online courses, they can be found at online.drchuck.com.